Good morning, students. We're back again on our lesson. And this lesson topic is method of showing relief on the map. In fact, before we start, how have you been coping with the COVID-19 saga? Please, I encourage everybody to be self-responsible so that we can come back again to meet face to face. Back to our lesson again. Method of showing relief on the map. What is the objective of this lesson? What do I want you to learn at the end of it to have? Or before we even end the lesson? By the end of the lesson, the student should be able to, 1, explain the meaning of relief as used on the map, describe types of relief used on a topographical sheet or topographical sheets. 3, discuss the nature and scope of the general topography representation of the land on a map surface. Relief. What is relief? As a matter of fact, the big grammar you are hearing is just a method of representing signs and symbols on the map for every map user to understand it. And this method of representing all these things, showing mountains, showing hills, showing rivers, showing land, showing road junction, all these are what is called what? Relief. The highlands and the lowlands on the map are what we call what? Relief. As we progress into the lesson, you will get better detail of it. Relief can simply be described as a combination of height and slopes. Combination of heights and what? Slope. When you look at a map, to some extent to you see like just a plain paper being colored with different types of paint and ink, but that is not so. To a good map user, every inscription on the map makes meaning to him, or means something to somebody else, or represent a feature that was noted on the earth surface that is transferred on the paper for portability, for easy usage. So it shows the highlands and the lowlands in a region. It shows the highlands and the lowland of a region. Map actually shows where there is hill, where there is valley, where there is river, and all whatnot. Every single detail is represented on it. Every single detail from that topographical region or from that geographical region where the map is drawn to represent brings out this detail. Somehow these details might be a hill, might be a valley, a slope, a bend, a corner, etc. that is either rising and falling of the land. It also reveals and shows the shape of the land as well as the nature of slope. The nature of the land. Is the land an undulating land? You understand what I mean by undulating? A land that cave in and out, cave in and out. You understand what I mean by slope also? It is a common word we use. Okay. It also reveals and shows the shape of the land as well as the nature of slope on the land. Now, what are the various methods of showing these reliefs on the map? There are several of them, but we'll pick out some few here and discuss. You can get others by your personal research, and when we meet face to face, we can discuss them. Number one that is here, we have point elevation. 2, we have form lines. 3, we have contour methods. 5, we have hatches, etc. We will discuss them one after the other. What is point elevation? This is made up of 3 types, and they all indicate that a particular point on the Earth's surface is elevated above mean sea level. I repeat again that they are made up of 3 types. And on the map where point elevation is used, you will understand that it shows or indicate that a particular point on the Earth's surface is elevated above mean sea level. You know, mean sea level is a common language in geography where we make reference to it as, we used it to represent a feature that is above a sea level in any locality or in any geographical portion. So it's popularly known as mean sea level. And this particular point on the Earth's surface is elevated above the mean sea level. For example, spot height, trigonometric station, and benchmark. The 3 types of point elevation are trigonometric station, trigonometrical station, benchmark, and spot height. Do I take that again for you? Types of point elevation: spot height, trigonometrical stations, and benchmarks. Let's look at spot height now. Spot height. These are figures written on specific places of a map. You see, when you see the surface of a topographical sheet, sometimes you see figures written 2100, 3500, 2000. These are figures. These are figures written on specific portion, specific places of a map. 2, where the height above mean sea level has been determined by surveyors. I know most of you have seen surveyors in the field working, and sometimes you get to a surveyor's site, you see something like a peg being cut, sharpened at one end, and it is being pinned inside the ground. It is numbered. There is a number to it. Now, the height of that place has already been determined by the surveyor that was working in that site. That is an example of spot height. This represents the surveyor's pillars. All of us in our various homes, you see pillars now, showing the end of our land to our neighbor's own. Now, on that pillar, if you check, there is a number, numbering that is there. That is an example of spot height. This becomes the point where cartographers draw contour lines. For any cartographer to sit down to say he wants to make a contour line, you must take it from a spot height, a certain level. That is why when you see contours on the map, the contours are drawn at interval. They are drawn at an interval. It might be 50, it might be 100, it might be 150. As the case may be, it is drawn at interval. Trigonometrical station. Trigonometrical station. This represents the places from which the angle of triangulation are measured. Most of you are mathematicians. You understand what we mean by angle of triangulation. So trigonometrical stations represents the places from which the angle of triangulations are measured. 2. They are usually marked on the ground by concrete pillars, just like in the case of spot heights. They represent places of accurately fixed height. They represent places of accurately fixed height. That is, the height has been determined and is fixed. They are diagrammatically represented thus. We have what we call the primary trigonometrical station, secondary trigonometrical station, and tertiary trigonometrical stations. The symbols are here. For example, a triangle with a dot inside and a numbering by the side. You get to a place, you see a triangle with a big dot inside, tick, with a numbering 5000. That height has already been determined. That height has already been determined. That is called a trigonometrical station on a map. You see on the map there. Secondary trigonometrical station. You see that triangle faced down with a dot inside, a thick dot inside. With probably a number 4100 written at the side of it. That is a secondary trigonometrical word station. You see it on your map sheets when you are given. These features I'm telling you are represented on the map sheets. But in the physically, if you get to a construction site, you can see some of these figures also. So it is the figures obtained from the land that is brought to the paper, for you to see and use. The third one, the tertiary trigonometrical station. When you see a circle, a perfect circle with a big dot inside, that shows that this is a tertiary trigonometrical word station, stroke minor trigonometrical station. tertiary and minor. They can serve for both purposes. It is either a minor one or a tertiary trigonometrical station, showing you determined height on the map. So you don't need to stress yourself again. This height is this. Instead of giving you a plain map to explain, which will be difficult for you to determine the height because you were not there when the cartographers took its orientation. So they have given you the map. From here, walk. They can ask you this question. What is the highest point of so thing on the map? What is the highest contour line? What is the least contour lines? You can see some of these inscriptions at any of the regions of the map, showing you a determined height. It is just for you to identify it. And possibly if you are asked to enlarge a map, or you are asked to reduce a map and insert such feature, you know the area you are going to place it in the map, and you have your score. Benchmark. These are usually marked at side walls or bridges. Most of you have passed on a newly constructed road or a newly constructed bridge. For example, the bridges that are constructed in Port Harcourt within now. The 3 overhead bridges that are constructed. If you have a time, you walk closer, if not for fear of COVID-19, and you watch. There are certain numbers allocated or written on the walls of the bridge. That is called a benchmark. These are benchmark. It is used by cartographers, used on the construction sites. Determine height. They show exact height above mean sea level. They are called reference mark in surveying. Reference mark in what? Surveying. They are shown on the map as follows. You can see BM 200, BM 3000, or they can write BM 300/1. Those are just figures and they are benchmark to determine the height above mean sea level. Form lines. They are approximated contours. Approximated contours. You know what I mean by approximation now? You approximate figures in mathematics. It is not up to that figure, but you said, because there is a standard law in it, you approximate the figures to the next whole number. They are sketched in between accurately surveyed contour lines. They are sketched in between accurately surveyed contour lines on the map. They are carefully placed in between 2 contours that were placed, and you assume that this one, there should be a contour line that should come in between here. That is why when you look on your topographical sheet, it is not all the lines that are numbered. In some region, all the contour lines that are numbered. Initially, if you have not known, contour lines are lines joining places of equal height on a map. I repeat again, contour lines are lines joining places of equal height on a map. So when you look at a perfectly or accurately drawn contour line on a map, you see in between it, you see another free lines, contour lines drawn without an interval. That is a form line. Most times they appear as broken lines. Most times they are not complete. Contour line, even though it crisscrosses south to west, to north, to east, this and that, and comes down. It is the same graduation. But this one can disappear in the line. It does not follow that pattern, but it is used to represent something. Hatches. The process of using hatches to depict relief is called hatching. The process of using hatches to depict relief is called hatching. It involves the use of strokes to construct slopes. It involves the use of strokes, 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 to construct a slope. It was one of the earliest methods used in representing relief on the map. It gives good visual impression, but does not allow much geographical information to be shown on the map, e.g., actual height are not shown. Actual height are not shown. When you see hatches on the map, good visual impression it will present to you, but there are certain details that are omitted in using hatches. But for aesthetic view, sometimes it is used for decoration, used to make the surface very plain for you to understand it. Layering. It is simply layer shading and layer coloring. It takes the form of different densities of shading for different heights. A cartographer might decide to use a shading pattern that every different layer takes a different shading. You know how to shade now. When we were in the basic section, or when you were in JS1, JS2, the fine and applied art to teach you how to shade your drawing. You shade where light comes in and where the light does not come in at a particular time. So you know how to give different visual shading to a particular object you are drawing. It takes the form of different densities of shading for different heights. Yes. 3. In the case of contour layering or coloring, the different levels of heights are given different colors, e.g. blue for sea, light green and deep green for land, violet as the height increases. It is often used in modern day atlas. That is why when you see atlas, if you open your atlas this day, you see some beautiful drawings with coloring. That coloring is called layering. Color relief maps are beautiful and attractive with good visual impression, but they give a wrong impression of sharp breaks from one relief region to another. With this, we come to the end of this lesson.